Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Forbidden Desert by Damo89. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 box. We have snakes, where we need to two snakes exist in the grid, and their ends are marked by headstones. So these are the headstones of the snakes. Snakes move orthogonally, which means that they either go horizontally or vertically, but do not cross themselves or share cells with each other. So that means these two cannot be essentially, well, I guess they could be. Huh. You could have a snake going something like this, and then another snake going around it, I guess. That's hard to see. But they cannot cross themselves or share cells with each other. So you can't be going like, I don't know, doubling back on itself, essentially. I guess it could be something like this, though. It could be something like this. As long as it's not going crossing itself, it could be something like that. That would be valid. So the snakes can move orthogonally, but cannot cross themselves or share cells with each other. So this would not be... if we tried going... If this was a snake here, this could not be the other snake here, because it would share a cell here, which is not allowed. And one snake is a German whisper, which is adjacent digits differ by at least 5. And one is a palindrome, where the digits read the same backwards and forwards. Oh, that's interesting. That does sort of imply something. Huh. So if this were, say, a palindrome snake, say this was a snake here, and this was a palindrome snake, then this would read the same going this way as it does going this way. Say it was a German whisper line. If this were, say, a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9. Interesting. That we'll get to that more in the information. We also need to draw your path through the grid from row 2, column 1 to row 9, column 9. Your path moves orthogonally, which means horizontally and vertically only, and visits any cell. I think it's supposed to be C, and cannot visit any cell more than once. Because it's very weird to basically have to visit any cell more than once. Have to visit every cell. So I think it's supposed to be your path moves orthogonally and cannot visit any cell more than once. That makes a lot more sense than and must visit any cell more than once. It doesn't make any sense to have that. Okay. Your path does not visit any cell containing a snake. Your path goes through every cell containing the digit corresponding to its box number. That is the one in box 1. So the boxes in order. This is are in typical Western reading notation, which is from left to right and top to bottom. So, for example, this, well, not example, this is box 1 here. This is box 2, box 3, this is box 4 here. And then we have box 5, box 6, 7, 8, and 9. So so the path has to go through the digit corresponding to its box number. So in this box number, it must go through the 1. In this box number, it must go through the 2, etc., etc. So that means the path has to go through every box, necessarily. And digits along your path differ by at least 2. So it's a whisper 2 line. So the snake, one of the snakes is a German whisper, or a whisper 5 line, as I like to call them. And this path is a whisper 2 line. In addition, path digits differ from any orthogonally adjacent snake cell by at least 2. Interesting. So for any snake that this is next to, it has to basically, any snake cell that the path is next to, it must be differ from that snake cell by at least 2. So in addition to being a whisper 2 line where adjacent digits cannot differ by at least 2, have to differ by at least 2 or more in the same, if they are on the same path, you have to differ by at least 2 from adjacent snake cells also. Candles can contain neither snake nor path. So the snake cannot go through the candles, and the path cannot go through candles. And then finally we have X, where digits on an X sum to 10, no negative constraint. So for example, if this were, say, a 3, this would have to be a 7, because these two digits must add up to 10. Okay, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's mark the path as blue. I don't know why, but these have to be blue. So, for the snakes, one of them is a German whisper, or as I like to call them, a whisper 5 line. The other is a palindrome, which means it reads the same forwards and backwards. And the gravestones are where their ends are, or headstones are where their ends are. So, if we try to have these match with each other, with the digit that, or the headstone that's in the same row or the same column, that will not work, because you're guaranteed that the gravestone for the palindrome line would be in the same row or column. And therefore, they could not be the same cell, which would counter its definition as a palindrome line. So these must match, essentially, how I marked them in the beginning. So this, we're going to mark one of them as pink, and we're going to mark one of them as orange. The pink and this pink must basically form a snake. And this cell and this cell must form a snake. We're going to make those, Yellow's not good either. Let's make them dark. A medium gray will be neither of them are valid. Okay. So, the question, okay, so blue has to essentially go around, cannot be touching the pink cells, cannot be in the same cells as the pink cells or the dark cells. Well, they can't be in the same cells as the gray cells either. So, can the pink cells be the one that's crossing? If that's the case, I don't think that's possible. If the pink is crossing, the dark cells have to go around it, but then they're blocked by the blue, right? So if the pink is in the middle, the dark cells have to go around it because they can't share a cell with the pink cells, and they can only move orthogonally. And it's blocked by the blue because the dark cells and the blue cells can never share a cell. So the dark cells have to go across, essentially, in some way. And the pinks have to loop around those. Well, if this pink tried to loop this way around this cell, so you would have essentially some sort of black snake going this way. And if you tried to loop going this way, the problem is the blues would not be able to do that. The blues would not be able to connect because we have this area being blocked. So the darks have to do something like this, going across, and the pinks have to essentially go this way. So this is guaranteed to be pink here. Blue has to go this way to match up. Pink could go something like that. That would be fine. We don't know what these are necessarily. So blue has to go this way. Pink has to go this way. Blue has to get to every box. And the problem with blue going to 4, it cannot go down. Because if it goes down, then it'll block the pink from connecting, right? So that means pink sort of has to block off this way in a sense. Blue has to get to 4 somehow and then go back out. If it tried going this way, right, it must enter 7 also. So I think this has to be blue, right? Yeah, it has to enter and then exit back out for the blue cells because the blue has to go to every box. So the blue has to definitely go this way because if it tries going this way, it's stuck. So this cannot be any digit. So it has to go this way. It could go this way, though. To reach 7, it has to enter in and then exit back out. So this is guaranteed to be blue. If it tries going, it could go that. So it could go through here, in which case it exits that way. Or it enters and exits this way. So this is guaranteed to be blue here. One of these is blue, the other one is dark. We don't know which is which. Therefore, pink has to go this way. Pink has to go this way. Okay. If it goes through here, I guess that's possible. So we're guaranteed a blue going through either here or here, right? And it has to either go this way and out, or it goes in and then goes that way. So pink could go like that. That means this does not go pink that way. Pink has to go this way. I guess, no, it could go around. It could technically do that. And then, no, it cannot. Well, it could. Blue could go something like that. And then go something funky like that. And then... What happens if dark goes this way? Okay. So if dark goes this way, it has to go out this way too. Then how would blue work? Blue would have to do something like... I guess it could do that, technically. That means 7 has to be one of these digits here. I think this is going to be hard to be a palindrome. I mean, maybe. So this technically could go this way. Okay. Of these options, okay, let's try this being, no. Let's try this being dark and this being blue. That means it has to enter from this way. That means pink has to go that way. Dark has to go out this way. Pink has to go here. So then pink can go here. Dark has to go this way, which means blues goes this way. That's interesting. So that would have to be an 8. This would not be 7. Pink could still go this way. We don't know. Okay, this doesn't seem that limiting, though. Well, this would have to be an 8. So this would be 8. This could not be 7 because there must be a difference of at least 2. So this would be 7 then, if that were the case. 4 would be one of these. This doesn't seem too limiting. Okay, let's look at the other way. Okay, so either way, this then becomes blue or dark also. This is blue or dark. So pink is always going to have to go this way. So that's always going to be pink. So this is going to be the same color going this way. So I guess we'll make that orange. And we'll make this. This also has to be the same color, so it's green. So pink is definitely going that way. This is going, this has to go this way. So then this has to go here. Right, because it can enter in and then exit back out. But either way, it still has to go this way, right? It cannot go back on itself and touch itself. That means orange must go this way. That means the blue has to enter from here, definitely. So it could be like, or exit that way. It could be entering here, then exiting that way. Or it could be entering this way and then exiting that way. The pink could go here, so that would be fine that way. I'm guessing that the pink cell has to be the German whisper line, or as I like to call it, the whisper 5 line. Okay, what happens if the greens are all essentially dark and the oranges are the blues? So that means dark has to connect here. So I guess this could be blue that way. Okay, so it does not have to go through here. Okay. Interesting. It's not, unfortunately, that doesn't limit things very much either. Um, Oh, that's interesting. What happens if pink is the Whisper 5 line? All of these digits are next to two unique digits on a Whisper 5 line. So it has to be 1, 2, 3, 7, 8, and 9 here, right? These are all next to two unique digits, right? This is next to that and that. This is next to that and that. This is next to that and that. These are next to these two. This is next to these two. This is next to these two. This is next to these two. So you're guaranteed all of these are 1, 2, 3, 7, 8, and 9 here. But 7 cannot be here in this box. 8 can't be here in this box because the path has to go through there. So then what does this look like? This has to have 1, 2, and 3 here with 8 and 9 in the middle. So this would be 8, 9 in the middle. I guess this would be 1 or 2 on the outside. This would have to be a 3. And this would be 1, 2, 7, 9. No 7, 9, 1, 2, 3. 1, 2, 3, 7, 9. So this would be 1 through 4 here. And it would have to go that way. This wouldn't be, this would be 7, 8, 9. 1, 2, 3. And this could be 6 through 9 here. No, it cannot be 6 through 9. It'd be next to two unique digits. So this can't be 3. This is a 1, 2 pair. This would have to be 7, 8, or 9 here. So 7 would have to be one of these two. That's fine. This would have to be a 4, 6 pair then. Which would mean this is 7 and this is 5. Therefore, this would have to be on the line. And this would be the other one as a palindrome. So far, that's looking okay. This would have to be 8. 4 would have to be one of the blues here. So the question is, can this ever be the palindrome line? I think the answer to that is no, right? Because the problem is this area here, right? So you can't have repeats here. Because it's going to be hard. So I think this is actually the correct solving line. So how do we make this a palindrome line? That means these digits are all different. Well, okay. The shortest one for this one is here, obviously. Then I guess we try to extend this the longest. So 1, 2. Okay, so if this is short, then it obviously can't be a palindrome line. That would be problematic. So the shortest times the shortest. These are the same. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And these would all have to be the same. So this could not be the palindrome line. What if we extended one of them to maybe as long as it can be? So this would be green. I guess this would be blue. Pink could go here. Blue has to still... Oh. Ah! That's problematic. You can't go that way. So say you did try to go this way. The green has to always go out this way. The blue has to always go out this way. But then so does the orange. But then the orange is blocked. So the pink here can never extend. And I think it works the same way on the other end. Right? So say the pink goes here as the minimum. then say it doesn't go here. Say it extends to here. That means orange has to go this way, blue has to go this way, and that blocks green from ever getting out, which it must. So we are almost guaranteed, not this one, but this one has to be here. It has to go here. It cannot extend out here. This cannot extend out here. It has to go through here. It has to go through here. Therefore, this is never a palindrome line, right? It's 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, and then these two would have to be the same digit, and these two would have to be the same digit. So this must be the German whisper line. So we're going to mark this as green, and this as red, pink, I guess. We don't know which one this is. So because of this, then the logic that I had previously works. This has to be 1, 2, 3, 7, 8, 9, because they're all next to 2 unique digits on the whisper 5 line. And 4 and 6 can only be next to 1 unique digit on a whisper 5 line. So this is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This cannot contain a 7 because a 7 has to be on the path, and this is the whisper 5 snake. So we have a 1, 2, 3, 8, 9 quintuplet in this box. Therefore, this must be alternating between low, high, low, high, low. And you'll always alternate between low and highs on a whisper 5 line, because what digits can be next to 1 through 4? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, 4 can be next to 9 only. So therefore, next to a low digit, you'll always have a high digit. And because of the same logic, you'll have high digit has to be next to a low digit. And the high digits are 6 through 9. So these must be low. This has to be an 8 or 9. I guess 3 doesn't have to be in the corner. This could be 1, 2, 3 there. This must be 7, 8, 9. This is 1, 2, 3. This is 7, 8, 9. Next to 1, 2, 3, 4. 1, 2, 3 is next to 7, 8, 9. Next to 1, 2, 3. Next to 7, 8, 9. But this digit is guaranteed. So 7, this can't be 1, 9, 2, 8, or 3, 7 because of the 1, 2, 3, 8, 9 quintuplet in the box. So it has to be 4, 6. That means where's the 5 and 7? The 7 has to be on the path, and this is the only way it can be path. So since this is path, this must be the blue. And this must be 7, which makes this 5. 3 cannot be next to... 3 has to be next to... cannot be next to a 7, and one of these is guaranteed to be 7. This has to be also 4, 5, and 6. And this must be 4, 5, and 6 because of the 1, 2, 3, 7, 8, 9 sextuplet in the rows and columns. So this cannot be 3. Therefore, in column 1, the 3 has to be one of these two. In row 9, the 3 has to be one of these two. If there's a 3 here, that would guarantee there's no 3 in row 9, so it's not allowed. So therefore, this does have to be 3 because of the logic I had. So this is 3 with 8 and 9. 1 and 2 here, 1 and 2 here. So this is dark. Oops. This is dark. Dark could go this way. Blue could go this way or this way. We don't know. Blue could go this way or this way. We don't know. This is 7. This digit has to be 8 because the path cannot get to here because that would block the dark snake from being next to itself. Actually, maybe we should make this medium gray and the others dark. That seems to make more sense, right? Because you cannot go through the really dark areas, but the medium gray is this palindrome line. Okay. This is 8, which eliminates 8 in the rest of the box. So this is a 7, 9 pair, which eliminates 7 and 9 in the rest of the row. So this is 8, which makes this 9. That means this can't be 9 here. This becomes a 7, 8 pair here. 1, 2, 3, 4 must go to this digit and cannot be 9 because of the 9 in the row. So this can't be 4. It's just 6, 7, or 8 here. Next to 1, 2, or 3. Okay. So gray has to go essentially through here. Blue has to enter and then exit. It could enter and exit this way, so that's fine. Blue can technically do something like that. That's fine. Blue could go here too. This is a 4, 5, 6 triplet, which eliminates 4, 5, and 6 in the rest of the box. So this must be 1, 2, 3, 7, 8, 9. And 7 and 8 cannot be here. So we have a 1, 2, 3, 9 quadruplet in box 9, which eliminates 1, 2, 3, and 9 in the rest of the box. Cannot be 1, 2, 3, or 9. It's 7 or 8 here. 9 has to be on the path for box 9. So it's one of those two. We're guaranteed a 3 here, so this cannot be 3 here. The remaining digits in row. So this is a 5, which makes this a 5 here to be a palindrome. This has to be 4, 5, or 6 because of the 1, 2, 3, 9 quadruplet in the row. And the 7, 8 already in the row. Remaining digits in box 1. We have 1, 2, 3, 7, 8, 9. 1 has to appear on the path, so it has to be one of these 3. We have, this can't be 7 or 8 in the column because of the 7, 8 in the row. 4 and 6 have to be somewhere here, guaranteed. And it has to be with 1, 2, 3, or 9 here. We don't know which. So we have a 7, 8 pair in one of these two digits. That means remaining digits in column 3 cannot be 7, 8, or 4, 6. So we have 1, 2, 3, 5. 6, 9. No 6. 1, 2, 3, 5, 9. 4 has to be one of these 3. That's fine. 4 and 6 have to be one of those 3. Remaining digits in row 8. We have no 5, 7, 8, or 9. So it's 1, 2, 3, 4, and 6 here. Okay. This 5 eliminates 5 here. So this is 4 or 6. On the Whisper 5 line, this digit cannot go here because it's 7 or 8 is not 5 or more away from 4, 5, or 6. So it has to go this way. So this is not anything. The blue has to go this way. This must be 1, 2, or 3. That means this has to be a 9 because that's the only digit remaining. So this cannot be 9 here, and 9 has to be next to 2 or 3. Okay. That eliminates 9 in the rest of the box. This 5 eliminates 5 here. We have a 1, 2, 3 triplet, which eliminates 1, 2, and 3 in the rest of the box, or the column. And this has to be at least 2 or more away from 7, so it cannot be 6. So this is 4, this is 6. It has to go this way. Cannot be 5 then, because it has to be at least 2 away from 6. Hmm. So the green is all done. It goes this way. Oops. Yeah, we don't need that, the line thing. Blue could go this way, blue could go this way, or this way. Hmm. Okay. Whichever way it goes, one of these digits is 4 or 6, and it must match that cell as a palindrome. One of these is a 5. Okay. Hmm. If this were 5, it would be 2 or more. It would not be 2 or more away from each other here. Right? 5 is consecutive with 4 and 6, so this cannot be 5. This must be 4, 6 as a pair. This can't be 4, 6, so this is 5. That means 5 has to be one of these 3 cells there. 5 is one of those 2 here. Five could be either of these. That's fine. Oof. Hmm. Okay. Hmm. Okay, this cannot go the whole length this way. Actually, it could. Never mind. This is not the Whisper 5 line. It's a Whisper 2 line. Never mind. Yeah, never mind. Hmm. Huh. Okay, what happened? So the green is all done. Oh, this is not medium. This has to be dark. Okay. The green is all done. Now we just need to figure out the palindrome. So say we had blue going some weird thing like this. That means the palindrome needs to go there. The blue still has to enter and exit this way. Otherwise, it would be crossing the medium. So it has to enter and exit from here. So that means it enters that way, it exits that way, it exits that way. So then it goes that. It doesn't have to go that way. It could go here. This has to go that way. That means this goes that way. This means gray has to go that way. And this could go either of those two. This still has to go that way, which means gray has to go that way. So then it connects either here or here, right? Does that even work? I don't think so. So these are the same. These two 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 are the same, and these two are the same. So we have definitely some along this essentially line would be a duplicate digit in the same column. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that would be the duplicate digit. So that's not possible then to go this way. So this has to go this way then. Guaranteed. This could be medium. Could be the snake going this way. So the snake just needs to avoid essentially two cells in the same row having to be the same digit. What happens if we try to make the blue go here from this way? So that would force blue to be there and this to be gray. So then the medium gray would have to go there. Blue would have to go up. So this blue would go up. So we know this cell is guaranteed to be on the loop or on the path. So we know this is always a blue. Right, because gray always has to go at least here. It could just go here, actually, technically. Oh, wait, no, it cannot go here. If it goes here, blue goes here and here, then that's fine. But gray cannot go here. Therefore, this is always gray. Interesting. So, yeah, if gray can go here and here. If it goes here, it has to go here. If it goes here, it cannot go here because then this blue goes here and then it's blocked. Cannot exit out. So the gray can, if it goes here, it has to go here also. Same with the blue. If the blue goes here, it has to go here. It cannot go here because then that would block the blue from getting out from here. This is 1, 2, 3, 4, 5. One of these is 6. That's a 7th digit. Huh. What else do we have? What are the possibilities here? Again, 1, 9, 2, 8, 3, 7, or 4, 6. But this can't be 6 and this can't be 4. That seems fine. Okay, one thing it cannot do is go 4 digits here, because then this digit would be the same as that digit. That doesn't tell us much. It couldn't go that way anyways, because it blocked the blue from ever getting out. Okay, so can it ever go this way here? I think the answer to that is no, right? Because again, you have to have blue going here, blue exiting out here. That forces the gray to connect there. And then these two cells would be the same. So if it goes this way, it has to go this way. If it goes this way, it has to go this way. So this is gray. This is the snake either way. So it matches 1, 2, 3, 4, 6. Whichever digit that is. Right? Interesting. Hmm. Okay. I think it has to come from this way. 1, 2, 3. Can it do some funky stuff? Maybe, I guess. Hmm. The question is, can it ever just come from here? And I think the answer to that is no. So you have 1, 2, 3, 4, 5, 6, 7 here. And the smallest path this way is 1, 2, 3, 4, 5, 6, 7 here. Either way, if it goes this way, it has to match either this cell or this cell if it goes the shortest route. So the question is, can this go this way without being going the shortest route? And I think the answer to that is no. This blue has to get out somewhere, right? Actually, we know, yeah, this blue goes out this way. It goes either here or here. This blue needs to get out here, so it has to go out that way too. So if we try to go from here, whatever way we go through here, and we try to go here, the problem is it can't connect here if it goes this way. What about if we try to do something like that? Maybe that works. So try going back and forth to here. Okay. You can't just go straight because then that would be the lowest common denominator. So it has to do something like this. Funky going that way. So then we have 1, 1, 2, 2. This is 3, 3, 3, 4, 4, 5, 5. Okay, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and that's 8. So that is possible then. It could go this way, as long as it goes like some funky shape there. Or it could just go this way, in which case that's okay too. Because then these would not be the same cell. So it could just go here. That's possible. Or it does some funky thing like that. Huh. Okay. Interesting. Hmm. So either it goes this way, or it goes like that. Some funky thing, or funky thing like that. That could work. Yeah. Hmm. Oh, that's interesting. So say it did do something like this. That means one of these is 2, 3, 4, 5, 6. 2, 3, 4, 5. That can't be 6 because that would be the same digit, so it would have to be there. But we are guaranteed along this line all the digits from 4, 5, and 6. So this line, then, because that matches these four. So, because if it's that, it cannot be this way. Because this, since all the digits from 4, 5, and 6 are on this line, that would eliminate all cells for this, all possibilities for this cell then. So it cannot just go straight up. So it has to do some funky, it could do some funky thing here too, maybe. So it cannot just go here and this straight up. It could do like this. That seemed to work okay. Can it do something funky like this? So if we tried going here, and then here, 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 here. The problem is, I guess maybe, that's 3. So that matches that 3. So say we tried to do something weird like that. So that would be 1, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. So this would be in the same thing. So the palindrome actually aspect is very restrictive. Actually, I didn't realize how restrictive it was. So if we tried going here, what if we tried going up and then doing some funky thing here? So this would be, okay, so we're going to mark these as so that we can figure out what these are. This is, let's make it big numbers. 3, 3, that's the fourth. I guess this would be, I guess it could do something like that. Fourth. Fifth. This would have to be fifth. The problem is this is 6 and one of these is 6. So it can't do that. So we tried going up. I guess it could do something maybe like that. Could that work? 3, 3, 4, 4, 5, 5, 6, and then one of those 6. 7, 7. Yeah, that does work, actually. Okay. Huh. Can it ever do something like this? I think the answer to that is no, right? I think it has to always include that cell there, which is very restrictive. So say we don't include any of these cells, or say we don't include this cell here. I mean, it could do something like that, potentially. Let's try... Okay, let's try it without touching any of those cells. I don't think that works, right? So let's just make this 3, 3. This is 4, 5, and one of these is 6. This is 7th. Okay. So if we go 4, 5, 6, 7, 8, that doesn't work. So you have to maybe include this. So can you do here? So 3, 4, 5, no, 6. So you can never get to here doing this, essentially, because then your guarantee is 6 here. So that would match this cell here. So you cannot do this way either. So that doesn't work. And we just tried this way, which doesn't work. 4, 5, 6, 7, which doesn't work. So you have to go this way then, because you can't go just straight down, because again, these digits are from all the digits from 4, 5, 6 in that box, and that eliminates all possibilities for that cell. So you have to, and we tried doing that, that doesn't work. We tried just not including either of these. If we try to go there, that doesn't work either because of the same problem with the 6s. So I think you have to go this way then. So that has to be the 4th one. So this is guaranteed to go this way, which means this must exit out this way. This must exit out this way, so this has to connect to here. It could do some funky stuff here. This could do some funky stuff here, but this has to go there. This has to go there. So this is the 4th one. So let's mark the path right now. It has to do, oops, center. Let's mark it in red. So it has to go here. It has to go this way. It has to go this way, and it has to go there. That's all we know. Actually, this part is not necessarily true. This could go this way, this could go that way, we don't know. This could go this way, that way, we don't know. This could turn that way, so it could do something like that. No, it cannot, because this has to go down. Okay, so there we go. So then this does have to go down that way. I don't think it could go here, right? That's 3, 4, 5, 6, and we have the same problem. So this cannot go that way, so it has to turn that way. So this is the 4th. Oops, I guess this is not 3 technically. So it has to go this way. So we'll mark that with a dark. Actually, we can just mark it all with red. That's fine too. So this goes that way. This has to go that way. So this is 1, 2, 3, 4, 6. This is 4, 5, and 6. This is whatever one of these two cells is. So then it must go down that way. So this matches this cell. And it connects. Okay, so then can it go this way? No. Because if it goes this way, so these cells match 4, 5, and then one of these is 6 with 6 here. These are both 7. So this matches down 7. And if it tries going this way, it would have to match that way going that way. So it's 8 and 8 in the same box, which is not allowed. So cannot go this way. It has to be one of these two, and this one is, so this matches that. So this is 1, 2, 3, 6, 7, 8, 9. Cannot be 6 because of the 6 in the row. So this cannot be 4 and 6. So this 4, 5, 6 matches here. This we don't know. It matches one of those two. So this must go to one of these two. This must go to one of those two. So this is nothing. Oh, wait. Not true. It could go back here. It could go here or it could go here. We don't know which way. Um. uh, okay, how does this work then? Obviously, this goes that way. This has to go all the way around here. You could technically do something like that, or like that. So these two digits are the same as those two, but that's not helpful. We have two digits from 4, 5, and 6 here. Hmm. Hmm. Okay. Oh, this digit has to be 2 or more away from this digit. So if it's 2, that would not be possible, so this cannot be 2. If this is 3, this would be 2 then, and that's not possible, so this has to be a 1, which means this can't be 1 here. That eliminates 1 in the rest of the box. So this cannot be 2 because that would be less than 2 away from 1. This has to be 3 because 2 is not 2 or more away from 1. That makes this a 2. So this makes this 1, which makes this 2, which makes this 1, so that's 2. So none of these can be 2 here. Where is the 2 in row 8? It has to be here. So this is 2, which eliminates 2 in the rest of the box. So these cannot be 3. It's a 2, 7, 8 triplet. This can't be 2, no 2 or 1. This can't be 2 or 1, no 2 or 1s. 3, 5, or 9 here. Why can't that be 5? I don't remember. Oh, because that's 2, that's not 2 or more away from 6. Okay. Therefore, this cannot be a 1-9 pair because, again, this matches this cell here. So this cannot be 1 and 9, so it's 2, 3, 2, 8, or 3, 7 here. We have 1 here, 3 here, 2, 7, 8 here. Hmm. We have a 4, 6 here. So one of these is 4, 6. The other one's 1, 3. So this cannot be 2 here. Okay. Hmm. What else do we have? Hmm. 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 Oh, this can't be 5 here because, again, in box 5, the path has to have contained the 5. So this is not 5 here. And that matches this cell here. So this can't be 5 here. Where's the 5 in box or row 7? It has to be here. So this is guaranteed to be 5, which eliminates 5 here. If this were 5, that could be 5. I mean, there doesn't seem to be a something that precludes that. This could go that way or it could go that way. 2, 7, 8. Okay. 2 can't be here and 2 can't be here. 2 could be here. That's possible. This can't be 3 because the 3 in the box must be on the path. So this can't be 3, but that's not too helpful, as this could be 3. If this is 5 matching that, that would be 5. That would seem fine here. What else do we have? Okay, so this digit cannot be 4. It either matches the 5 here, or it's whatever this digit is. But it cannot be... It would not be 5 in that situation. It cannot be 4, so it could be 1, 2, 3, 6... cannot be 6 because the 6 in this box 6 has to be on the path. So it'd be 1, 2, 3, 7, 8, 9. Cannot be 2 because of the 2 in the row. Okay. Six on the path would have to be here or here. Because it could go like something like that, it could go something like that, it could just go straight. It cannot enter here because that has no place to exit. 3 cannot be here. So 3 has to be one of these 3 or that cell. Don't know which. 2 is can be a lot of things. So it could be here or here. We don't know. Oh, this one, no, that can't be 3. Huh. 5 obviously is one of these stats. That doesn't really tell us much. Where's the 2? Well, in row 3, it's one of These two or that one. That's not telling us much. Boy. Where are we going with this now? This could be any digit. Okay, what happens if this is 3? That makes this not 3, so it's a 2-8 pair. That means this has to be 8. So this is so what happens if this is 3-7 is kind of a question, right? Does it? I don't know. Maybe, maybe not. Anyways, if this is 3, this cannot be 3-7. It's 2-8, which forces this to be 8, this to be 9, that to be 7. The 8 here means this can't be 3 or 7 or 8, so this must be 2, which makes this not 2, that's 8, that's 2. So far, that's okay. This cannot be 3. That can't be 3. This 8 eliminates 8 here, so it's 7. That seems fine. Ah, okay, one thing. That's helpful. Okay, this digit cannot be 6 because that's not 2 or more away from 7. So this is 4, that's 6, which makes this not 4, that's a 6. This can't be 6 here. So this is 6, which means one of these is 6. This must be 1 or 4. And this has to be a 6, right? No. This has to be a 6. So this is 6, which eliminates 6 as a possibility here. Okay. So that's good. 1 or 4, 1, 3, or 4. That's a 6. So 6 cannot be here, which means 6 has to be one of these two. That's interesting. Okay. So we know a 4 has to be one of those two. Um, 6 is one of those two. Not too helpful there. Oh, this can't be 7 or 8 here. Actually, it could be. No, it cannot be 7 or 8 here. Oh wait, no. This could be just nothing, right? It's not guaranteed to be. It's not a snake. It's not a snake. Never mind. So this can never be 5 here because it's next to a snake with 6. 5 could not be here either. So 5 in box 5 has to be one of these 4 cells. That doesn't tell us too much. Okay. 2 could be next to 7 or 8. That's fine. 5 is obviously one of those two. Okay, what are the possible digits here? There's a lot. That's the problem. I didn't want to go down this path. 1, 2, 3, 5, 6, 7, or 9. 6 and 7 and 9 are consecutive with 8. So that's not allowed. Um, hmm. Uh, So 3 and 8 seem to work okay. I don't know, maybe let's continue. 3 and 8 means this is 9, this is 7. So this would be 2, 8, and 2. Hmm. So this seems fine. I don't know. Remaining digits in column 6 would be 1, 4, and 7. Obviously, this can't be 1 because of the 1 in the row. This would not be 2. Hmm. Seems fine. Okay, well, that's too much assumptions there. This 6 has to be one of these two digits here. Okay, so one of those is a 6. Wait, can it go this way? Maybe. Yeah, maybe this is not correct. It could go this way, because I didn't think about that. 1, 2, 3, 4. Okay. Well, yeah, it still always has to go through here, though. That's guaranteed. So it either goes here or it goes here. So 6 is one of these two. But we don't actually know this cell. Oh, that's so... we're not guaranteed that. So it goes to one of those two and then one of those two. Oh man, going through all these possibilities is very... Oh, it kind of sucks, actually. Okay, let's think about what happens if we go that way. Obviously, that would be 6. Hmm. Let's say it went that way. Okay. Then this would be 6. This would be a 1 or 4. We'd have a 1, 3, 4 triplet in column 6. So this would be 2 and 8. So the last remaining digit would be 7 and 9 here. It would have to go through here. So this would be 7 or 9. Obviously, this couldn't be 2 anymore. I mean, it seems okay so far. Um, so far that seems fine. So many minute things you need to look out for. This is 6, which eliminates 6 here, so this is 4, which makes that 6. That 4 eliminates 4 here, so it's 1, which makes this 3. That makes this 8. This is 2, which makes this 8, which makes that 2. This would be 1, that's 4. So this is 4. Okay. That's okay. This would be 9, so this would be 7. That seems fine. This would have to go that way. So it'd have to go that way. That seems fine so far. Trying to figure out the possibilities that you can't have is kind of pretty annoying. This can't be 2 or 6. 1, 3 or 5 there. Cannot be 1. It's 3 or 5 there. 2. This 7 would eliminate 7 here, so it's 8. Which means neither of these could be 8. Remaining digits in row 1. Oh, there's so many possibilities. 2, 3, 4, 5, and 9. 5 cannot be here. This can't be 2 or 4. This cannot be 9 because that would, well, actually it could be. We're not guaranteed that's on the line, on the path. 3, 5, or 9 here. Remaining digits in column 5 would be 1, 3, 5, 7, 8, 9. 8 cannot be any of these. This can't be, there cannot be a 1 here. This can't be 3 or 5. This can't be 7. So it's 8 or 9 there, guaranteed. This can't be 5 or 9. Interesting. This is a little problematic. This can't be 5. Okay. This can't be 1 because of the 1 in the row. This can't be 5 or 7 because that's consecutive with 6, which is a snake. This can't be 3 because that would be next to 4, which is consecutive with a snake. This then cannot be 8. That forces this to be 7 and 9. Ah, we have a problem because of that contradiction. So no, it cannot go this way. Jeez. That was all a lot just to prove that that can't go that way. That's kind of annoying. Huh. Okay, so then we do. No, this is 1, 4. So this has to go this way. This is matching than this. Because we tried going this way and that didn't work. Remaining digits in column 5. Maybe we just have to do that. 1, 3, 4, 5, 7, 8, 9. This can't be 3 or 5. This can't be 4 or 5. This can't be 1 because of the 1 in the row. This again cannot be 5 or 7 because it's next to a 6 on a snake. This can't be 5 because if it's not on the snake, it can't be a 5. If it is on the snake, or sorry, path, it can't be a 5. If it is on the snake, it's next to a 6, and that's not allowed. For 5 to be next to 6 if the snake is the snake's 6 and 5 is on the path. This is pretty hairy for the last part. I'm not sure I like this as much. All the other stuff was really cool. It was really cool logic, but this part is kind of just annoying because you have to go through all the possibilities and just cancel some possibilities just because of some way that it turns or whatnot, and it's just kind of annoying. Okay, remaining digits in box 3. You know 6, so 1, 2, 3, 4, no 5, no 6, 7, 8, 9. 4 cannot be consecutive with the 5. This can't be 3 because of 3 in the row. This can't be 4 because of the 4 being one of these two digits. Hmm. What happens if we go 6 here? So we know we can't go this way, but what happens if we just go here? So if this is 6, this obviously can't be 6 here. That means this is 4, which makes that 6. Oh, and it's, no, there we go. Okay, so that's something there at least. This 3 cannot be consecutive with 4 because this 3 is on the snake. So this must be 6, which makes that 4, which means this cannot be 6, so that cannot be the snake. So the snake has to go here because it has to be 6. So this is 6, and the snake goes this way. This 6 eliminates 6 here, so it's 4, which eliminates 4 on the rest of the box. This can no longer be 4 because of 4 in... This can't be 1 because of 1 and 4 in the row. This can't be 4. Where is the 6 then in row 1? Can't be here. Can't be here. Can't be these two because of the 6s in the column. So this must be a 6 here. That eliminates 6 in the rest of this row. Okay. We should have... this 6 eliminates 6 here. So this must be 6 here. Which makes this 5, which makes that 6. Because again, the 6 has to be on the path. It cannot enter here and then exit back out. So this must be on the path, but we don't know if it does something funky like that or funky like that. That should be all the 6s though. 1, 2, 3. This is a 5, that's fine. That leaves this as a 5 because there's no other place for it in row 1. So this is a 5, which eliminates 5 here. So that means one of these 3 is a 5 and must be on the path. Remaining digits in row 1. 2, 3, 7, 8, 9. Okay. What about remaining digits in column 4? 1, 2, 3, 4, 5, 7, or 9. This can't be 1, this can't be 2, this can't be 5 or 9. This can't be 5 or 3. This can't be 4. Remaining digits here. 1, 2, no 3. I guess it could be. No, it can't be 3. 1, 2, 4, 7, 8, 9. Okay. Um. Hmm. We do know 7, 8, 9 all have to be here somewhere. But it could be 7, 8, and 9 spaced apart like this, right? It's not guarantee. This is kind of annoying. Okay, where is the 4 in column 9? 4 cannot be here. This can't be 4 because it's consecutive with the 5, which is on the snake adjacent to it. 4 cannot be here. So 4 cannot be here because of the 4 in the box. So 4 has to be one of these 2 digits there. Okay. Does that tell us much? I don't really know. I'm just sort of like confused. One of these is a 4 then. This can't be 4 because of 4 in the row. Interesting. 4 has to be one of these digits. Okay, so no difference of at least 2, 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 difference of 2, difference of 2, difference of 2. Same here, same here. There doesn't need to be a difference between the snakes. Difference of at least 2. This can't be 7 because that would be next to a 6 on the snake and consecutive with it. None of these can be 9 because of the 9 in the row. So 7 has to be one of those 3. This is hairy. 2 eliminates 2 here. Remaining digits in column 8 are 1, 3, 7, 8, 9. Okay. This can't be 1 because of 1 in the row. Where is the 5 in row 5? Can't be here because it's 5 in the column. Can't be here because it's next to an X. Can't be here because it matches that cell. Can't be here because 5 in the column. Can't be here because it would be a difference of less than 2 between this 5 and 6. So this must be a 5, which eliminates 5 in the rest of the box. So this is a blue, guaranteed. Oh boy. Remaining digits in row 5 are 2, 3, 4, 7, 8, 9. And 7 cannot be here because this digit would be less than 2 away from this cell. Also, there's a 5 in the column here, so that's why this couldn't be 5. So this is guaranteed to be on the path. We don't know which way it goes. So this is 1, 2, 3. This cannot be 3. If this is 3, that would force this to be 4. And then you'd have on the path adjacent digits or consecutive digits, which are less than 2 apart. So this cannot be 3. Similarly, this can't be 3 either. Cannot be 5. Remaining digits are 1, no 2, no 3, no, it could be 4, no 5, 6, 7, 8, or 9. Those are the possibilities. Okay. 4 is one of these 3 digits. This can't be 4. Well, it could be. Interesting. Hmm. Remaining digits here. 1 through 4. 7, 8, 9. No 3, obviously, because of the 3 in the row. But that's pretty wide. If this is not 2, 8 as a pair, where is the 2 in row 5? It has to be here. So this can never be 8 here. Because if that were 8, that would mean this is a 3, 7 pair, but then there'd be no place to place the 2 in row 5. Oh, well, okay. This can't be 5 because of the 5 in the column. You could actually do something like this. So I kind of messed that up a little bit, but it's fine because we found this can't be 5, so then therefore that must be 5. Hmm. This is so kind of painful. Going through all the possibilities. Ugh. Hmm. If, well, no, it could be 3, 1. That would be possible. One of these 3 is a 2, but that doesn't help much. This cell's the same as that. This cell's the same as that. Okay, so this cell's the same as that, so it must be one of these 2 cells there. That's not helpful. Well, okay. If this were 4, this would be 1. So this is very restrictive. 4 and 1. Wait, other way around. This is 1 and this is 4. So 4 would have to be here. It cannot connect to here, so it would have to connect to here. And then here. So 4 cannot be consecutive with 3 or 5, so this would be 9, that would be 3, this would be 5. This would have to go that way. And it cannot be 1. So far that's okay. This can't be 3 because that's consecutive with that. So it's 2 or 7. This can't be 4. We have 2, 7, 9 triplet. That forces this to be 3. 3 to 5. That means this cannot be 3 or 7. It's a two-way pair. So far, this is looking fine. This can't be 2s. No 3. No 3. No 8 here. This can't be 4. No 4. It connects to here. That's looking fine. This has to be a 4 then. Because this can no longer be 4. This is just so painful. 2 has to be one of these two. This can't be 1. This is 3. That forces this to be 8, 9. 2, 8 as a pair. Therefore, this is 1, 7. This can't be. This is 1. That's 7. This is 4. This can't be 1, 4, or 7. We have 8 or 9. If this were 8, that would force this to be 9. So this cannot be 8. This is not 3 or 8. It's 1 or 9. Not 3 or 8. It's 1, 7, 9, which forces this to be 3. I mean, this is looking fine. This can't be 9. That's 8. This can't be 7, so this is 2. This is 9. This 9 eliminates 9 here, so it's 1, which makes this 7 or 9, which is fine. This would have to be either 5 or 7 or 9. No 1, no 4, no 9. So this matches again one of those two. We don't know which. Where's the 3? It has to be here. This one eliminates 1 here, so it's 3. Jeez. Seriously? I have to go through all of this rigmarole just to try to disprove this. This is annoying now. This 2 eliminates 2 here. This can't be 2, so that's 8, which makes this... Oh, and then we have a Yay, we have a contradiction. Way the heck after this? That's kind of ridiculous. To have to try to prove that. I don't even know. I don't even remember what the assumption here was. The assumption... Yeah, just I'm not happy with this. Everything else was really cool, and then this has just been basically just a pain. So this was assuming this was 1. That forces this to be 4. So then this must be 4. That's such a... Ugh. So this is 4, which means this can't be 4. This is not 4. We have a 1, 3, 1, 3 pair then in column 6, which eliminates 1, 3 in the rest of the column. So this is 2, 8. This is 2 and 8 here, which eliminates 2 and 8 in the rest of the row. And the rest of the column here, so this can't be 2 and 8, which means this can't be 2. This can't be 3 or 1 because of the 1, 3 pair in the column. That leaves a 7, 9 pair in column 6, which eliminates 7, 9 from the cell, so that's 4. That eliminates 4 in the rest of the box. Okay. That means this can't be 4 here, so one of the 4s is one of these two cells there. This can't be 2 anymore because of the 2, 8 pair in the row. Where is the 2? in box 6. Cannot be here because of 2 in the column. Can't be here because 2 in the row. Can't be here because of the 2-8 pair in the row. So 2 has to be one of these 2 digits here, which eliminates 2 in the rest of the column. Okay. Okay. This 2-8 pair eliminates 2-8 in the rest of the box. So this can't be 8. This can't be 2. No 8 here. That means 2 has to be one of these 2 digits here. So if we had a 1 here or a 3 here, it would be consecutive with the 2, guaranteed. So this cannot be 1 or 3. We have a 2, 7, 9 triplet then, which eliminates 2, 7, 9 from the rest of the column. So this can't be 2, 7, or 9. So this is 1 or 3. 1 or 3 would definitely be consecutive with 2, so this cannot be 2. This is 7, which makes this 2, which makes this not 2 here. So where's the 2 in box 1? It has to be here. That eliminates 2 here, 2 here. This 7 eliminates 7 here. If it tried going this way, the problem is that 7 and 8 are consecutive with each other. So it cannot go this way. Therefore, it must go this way and then connect through here. That means that this cannot be 7 because 7 is consecutive with 6. So this is 8, this is 7. That eliminates 7 in the rest of this row. That means 8 cannot be here. We have a 3, 7, 9 triplet in... why can't that be 2? Oh, because one of these has to be 2. We have a 3, 7, 9 triplet in row 1, which eliminates 3, 7, 9 in the rest of the row. So this has to be 2. 2 cannot be consecutive with 1, cannot be consecutive with 3. So 3 is one of these 2. We don't know about this. This 7 eliminates 7 here, so this is 9, which makes a 7. This cannot be 3 anymore, because if it were 3, it cannot be next to a 7 on a Whisper 5 line. So this is 1, which makes this 3, which makes this 3. These are the same digit. That eliminates 3 in the... This 7 eliminates 7 here, so it's 9. That 9 eliminates 9 here, so it's 7, which makes this a 3. That means this can't be 3 here. This can't be 3 here. We need a 3 in column 9. Can't be here because of 3 in the box. Can't be here. I'm not sure why. Yeah, it can't be here. Oh, I remember. Can't be here because the 3 would be consecutive with the 4, guaranteed, and they would be on the same path. So therefore, it must be here. So this is 3, which forces this to be 9, that to be 1. This has to be on the path, so it must go this way. And this is on the path, so then it has to go like that. So then this is the path. Okay. This can't be 9 because of the 9 in the box. This is a 1-8 pair, which eliminates 1 and 8 in the rest of the column. This can't be 3 because of 3 in the rest of the column. We have 4, 7, and 9 here. Okay. If this is 8, this would if this is 8, this would guarantee this is a 9, and that would be consecutive, so that's not possible. So this has to be 1, which makes this 8, which makes that 1. That means 1 cannot be here, 1 cannot be rest of these digits. 4 is one of these. This digit cannot be 7 or 8 or 9. 9 is actually eliminated from this possibility. This 7 eliminates 7 here, so it's 3, which means this can't be 3. This must be 1. This can't be 1, 3, or 7. It's 8. So 8 cannot be here. This can't be 8. This 8 eliminates 8 here, so it's 7 and 8. This 8 eliminates 8 here, so it's 2 and 8, which means this is a 2. 3 eliminates 3 here, so it's 9. So this cannot be 9 here or here. This can't be 9. This can't be 9, so it's just 4, which makes this 7. 4 cannot be here. Okay, this can't be 1 or 8 or 3. So in this 7 eliminates 7 here. So this is 9, which makes this 4. That means this can't be 7 or 9. It's 5, which means this is matching here. That leaves this digit as 7, which makes this 9. 1 eliminates 1 here, so it's 3, which makes that 1. 5 eliminates 5 here, so it's 3. So if it tried going here, it would be touching the snake orthogonally, and so this cannot be on the path. So it must go this way. Okay, dude. So that means it has to go that way. So that means this is the snake. This is the path going that way. It could go here. It cannot go here, because if it goes here, then these would be touching each other on the path. So this is not something. This is not something. So this is the palindrome snake. Okay, this 7 eliminates 7 here, so this is 8, which makes this 7. This 9 eliminates 9 here, so that's 8, which makes this 9. So how does this go this way? Cannot go this way, because it would be touching a snake orthogonally. So then it must go this way and then this way. And that is the entire path. So 6 to 4, difference of 2, difference of at least 2. 6, 4, 1, 8, 6, 2, 7, 1, 5, 9, 6, 4, 7, 4, 8, 3, 9, 7, 4, 8, 1, 5, 9, 3, 7, 2, 8, 1, 9, 4, 6, 1, 9, 3, 7, 5. And none of them are consecutive with each other. What about with snakes? 3 is not consecutive with 1 or 6. 2 is not consecutive with 6. 1 is not consecutive with 6. 8 is not consecutive with 4. 2 is not consecutive with 7. 5 is not consecutive with 7. 6 is not consecutive with 4. 4 is not consecutive with 8. 6 is not consecutive with 8 or 9. 2 is not consecutive with 9. 6 is not consecutive with 4. 3 is not consecutive with 8. 5 is not consecutive with 7 or 8. 6 is not consecutive with 1. 7 is not consecutive with 1. 2 is not consecutive with 9 or 7. And that's done. So then this is a 9. Oh, and this is a 5. Holy moly, well done. Yeah, this was... The first part was really cool. The last part, trying to differentiate them, was kind of just a pain. You just had to go through all the different possibilities to basically make, and even then, like I had missed certain possibilities, and then I realized them later, and there's a lot of little small details which you have to go through. I would consider this harder than hard. I think this is very hard. Anyways, I hope you enjoyed this solve, even if you saw me struggling through it, trying to figure out all the little minutia detail. The first part was really fun. The second part, not so much, but, you know, we got to a satisfying resolution. Anyways, I'll see you next time on Frank Puzzles. Take care.